Today we're going to be studying special right triangles. The first kind of right triangle that we're going to study is a 45, 45, 90 triangle. The reason it's called a 45, 45, 90 triangle is because it's actually describing the angle measurement. So I know I have a right angle and I have two 45-degree angles. Now notice if those two are both 45-degree angles, that means that I have a right isosceles triangle. So I have two congruent sides. So what we're going to be doing is, in a minute, Mrs. Gabrielle is going to be giving you a worksheet that has I think 8 right triangles on there, isosceles right triangles, that we are going to count their sides, measure their sides, and then calculate the third side, the unknown side. So up here I have an example of what you're going to be seeing. I only have 2 examples, but you should be able to get the idea of what I need you to do. So now let's take a look at my first triangle. I can see that I have a side length of 2, so I'm just counting the units. I have a side length of 2 here. And I can also count that my units here at the bottom is also 2. What I can do now is, since I know that I have a right triangle, and you can see that here, we know we have a right triangle, we can use the Pythagorean theorem. So I know that 2 squared plus 2 squared should equal my hypotenuse squared. Through the magic of math, we have 4 plus 4 equals c squared, and we have 8 equals c squared. Now, the thing is, I want you to put your calculators away. We do not want a decimal form of this. We want to just simplify the radical. So I know c is equal to radical 8, and I need to think back to your Algebra 2 days and maybe even your Algebra 1 days. We need to factor out a radical 4. If I do that, that means I have radical 4 times radical 2, and radical 4 simplifies, I can't even say the word today, simplifies to 2 radical 2. So I know that c, or my hypotenuse, is 2 radical 2. And that is the way I want you to leave your answer. Let's do one more like that together. We have a smaller triangle up here at the top. I can count that each side has a unit of 1 here. My leg has a unit of 1, and this leg has a unit of 1. And now what I need to do is solve for my hypotenuse. So I have 1 squared plus 1 squared equals my hypotenuse squared. 1 plus 1 then should equal c squared, so we know c squared is equal to 2. Again, we need to take the square root. C equals radical 2. Now this is already simplified, so I'm going to write my hypotenuse up here. I have radical 2. What I would like you to do is go ahead and complete this, or repeat this whole process now for the 8 triangles on your paper. And Mrs. Gabrielle is going to pause the movie, and when you're all ready and done and ready to go on to the next part, she's going to hit play again. Okay, I'm hoping that after you completed several of those, you're starting to see a bit of a pattern. So let's take a look and see if we can come up with what we call a formula triangle. Meaning I'm going to be able to come up with a generic triangle that I can apply to any triangle, or any 45, 45, 90 triangle. So again, we have my isosceles triangle, and my 2 legs are congruent. So we are going to refer to those as x. That's something we can count, like what we did on our dot paper. We were able to count those leg lengths. Now, I hope you noticed too, as you went through this process, the number that sits in front of your radical, in this case there's a 1, that is the length of the legs. So that means that when I come back to my formula triangle, the length of the hypotenuse is the length of the leg times radical 2. This is our formula triangle. We are going to use this, or at least think about this, every time we try to apply it to another 45, 45, 90 triangle. So make sure that you have this written down. Mrs. Gabrielle is going to be giving you a sheet that has for you formula triangle on top and a formula triangle on the bottom. The bottom triangle is what we're looking at right now, the 45, 45, 90. So now let's use our formula triangle here to do a couple example problems. Here's our first one. I brought my formula triangle along with us so that we can use that, refer to it. So I'm going to look at my example. I noticed that 12 is a leg length. So I know it's easy to find my other leg length. That's not a problem. But we want to use this now to find the length of the hypotenuse without having to do the Pythagorean theorem. So I noticed 12 matches up with x on my formula triangle. And I know my hypotenuse here matches up with x radical 2 on my formula triangle. So that means whatever the length of my leg is, I need to take it times radical 2 in order to get the length of the hypotenuse. So that means the length of my hypotenuse is actually 12 radical 2. That's all there is to do with it. No other simplifying you can do. That is your answer. Let's try another example. Here's another example. This time I'm given my hypotenuse. My hypotenuse is 15 radical 2. And I'm noticing that that matches up with my hypotenuse on my formula triangle. So I'm going to set those two values equal to each other. So I know that x radical 2 should equal 15 radical 2. Mathematically, then we need to solve for x. Let me get this out of the way a little bit. We know we need to solve for x. So I'm going to divide both sides by radical 2. Radical 2's cancel, and we get x equals 15. Which means that my two side lengths are 15. Now, I'm sure you could have figured out that whatever number is sitting in front of the radical 2 is your side length. But the reason I showed you this way, as far as solving it and setting it up, setting the formula triangle and the example equal to each other, because that can be very handy. The reason it can be very handy is because we don't always have such a pretty problem where you get 15 radical 2 or 12 radical 2 or some measurement times radical 2. Let's look at one of those next. Let me grab my formula triangle, take it along with us. So here we have it. We have our formula triangle, and we have our example. This time we're given that the hypotenuse is 12. So now I want to match up my hypotenuse of my example problem to the hypotenuse of my formula triangle. So I know that x radical 2 has to equal 12. They're in the same positions on the two triangles. So if I want to solve for x, I need to divide both sides by radical 2. When I do that, my radical 2's cancel, and I'm left with x equals 12 over radical 2. But remember back to your algebra 2 days, we do not like radicals in the denominator. We need to rationalize that denominator. In order to do that, we need to multiply by a factor of 1, meaning I need to multiply by radical 2 over radical 2. When that happens, 12 times radical 2 just gives me 12 radical 2. But watch the denominator. The denominator is radical 2 times radical 2, which is equal to radical 4. So radical 4 goes in my denominator. That's a 3. We can actually simplify that even further. Radical 4. Okay, so now we can simplify this even further. We have 12 radical 2 over, goodness, I must like the number 3 today. We have 12 radical 4. Oh, that's all wrong. Let me start over. Back up a little bit here. I need to simplify 12 radical 2 over radical 4. To do that, what I'm going to do is take 12 radical 2 over 2. And now I can see that I can reduce this even further. 12 divided by 2 is 6, so I have 6 radical 2. Now keep in mind, that's x. That is what we are solving for. So x in our formula triangle, because we set the original side length up to the formula triangle, x in the original formula triangle is actually the length of the leg, right here. The length of both of these legs then is 6 radical 2. Let's try another one like that since I kind of butchered it a little bit. Let's make a new triangle. We're going to do the same thing here, where we have a hypotenuse that is not does not have a radical with it. There we go. That looks a little bit better. Okay, so let's say our hypotenuse is 10. We're going to have our hypotenuse be 10. We grab the formula triangle. And what we need to do now is solve for the length of the legs. So I'm telling you, you have a 45, 45, 90 triangle. We need to solve for the length of the legs. So I can see again, 10 is my hypotenuse. That needs to match up with the hypotenuse on the formula triangle. So what I'd like to do right now is I'm going to give you about 60 seconds here to go ahead and solve for x, which will then tell you the length of the two legs. So go ahead and do that now. Okay, so what we're going to do is take 10 and set that equal to x radical 2. Divide both sides by radical 2. And I know I cannot leave my radical 2 in the denominator, which means I need to multiply both the numerator and denominator by radical 2. If we do that, we get 10 radical 2 over radical 4, which is 2. So now 10 divided by 2 is 5. So my x is equal to 5 radical 2. And that is the length of the leg. All right, so that is the 45, 45, 90 triangle. We're now going to repeat this whole process for our other special right triangle, and that is the 30, 60, 90 triangle. Mrs. Gabrielle is going to be passing out to you another sheet full of 30, 60, 90 triangles. This time I think you only have 6 or 8, something to that effect. But anyways, it's going to look something like this. Now notice this dot paper is just a little bit different. The last dot paper that you had all made squares. That's why we were able to count the way we were. This dot paper makes equilateral triangles. We have to count on the diagonal. We're counting our units on the diagonal. So let's start with the large triangle here. I know that I can count this way, 1, 2, 3, because that's a length of a side of an equilateral triangle. So my unit here is 3. If I look at the diagonal piece here, my hypotenuse, I can count that that's 1, 2, 3, 4, 5, 6 units long. I cannot count the other leg because between dot to dot here, going from this dot to this dot, that is not the length of one of the sides of the equilateral triangle. So that is actually what we're going to have to solve for using our Pythagorean theorem. So let's do that. I know that 6 is my hypotenuse, 3 is a leg. So we can do 6 squared minus 3 squared equals a squared, x squared, whatever you'd like to use. So 36 minus 9 equals a squared. So I know a squared is equal to 27. Again, I don't want you to use your calculators. We need to simplify this radical. So a is equal to radical 27. I know I can factor out a radical 9. So the square root of 9 is 3. That's what's going outside. And then under the radical still is another 3. So a is equal to 3 radical 3. That is the length of the longest leg. 3 radical 3. Okay, so now repeat this process for the next triangle. The second triangle here, in the middle we have a side length of 2, and my hypotenuse is 4 long. Now, using the Pythagorean theorem, solve for the length of the longest leg. If we do that, we have 4 squared minus 2 squared equals a squared. 16 minus 4 equals a squared. We know a squared is equal to 12. Simplify your radical, you get a equals 2 radical 3. So the length of this side here is 2 radical 3. So what I'm going to have you do is, Mrs. Gabrielle will give you that sheet. You go ahead and do that for all of your triangles. And then again, we'll come back together. Okay, so we need to make a formula triangle again, just like we did for our 45, 45, 90s. Before we do that, let me remind you of something we learned a while back. We learned that the shortest side of a triangle is always opposite of the shortest angle. The largest angle of a triangle is always opposite of the largest side, which then means that the medium angle is across from the medium side. Okay, keeping that in mind, let's go ahead and figure out what we learned from our formula triangle. From our example triangle, sorry. So we knew we were able to count two pieces. We were able to count the short leg, and we were able to count the hypotenuse. So if you look at all your examples, you should be able to tell whatever the short leg was, the hypotenuse, the hypotenuse was twice as long. Whatever the short leg is, the hypotenuse has to be twice as long. So now, what about the relationship between the short leg and the longer leg? If we look at the relationship between the short leg and the longer leg, notice that all of the answers should have had radical 3. And the number that sits in front of the radical 3 is the length of the short leg. So going back to our formula triangle then, the length of the longer leg has to be x radical 3. And now we have a formula triangle for our 30, 60, 90 triangle. So go ahead and fill that in on your formula sheet. Go ahead and make your formula triangle on your formula sheet. So let's do some sample problems with this. Sample. We have our formula triangle along with us. Okay. We take our formula triangle along with us. In our example, we are given the hypotenuse. We are given the hypotenuse. I know that has to match up with the hypotenuse on my formula triangle. So that means that 2x has to equal 8. Those two pieces have to be equal. So that means that x equals 4. So what that tells me is that x on my formula triangle is the short leg. So that means that the short leg has to have a length of 4. So now my longer leg is the formula triangle says is x radical 3. Whatever my short leg is times radical 3. In my example problem, my short leg measures 4, which means my long leg has to be 4 radical 3. And you're done. Now again, I'm sure that you probably did not need to set up this equation here to figure out that x equals 4. But again, there's a method to the madness because sometimes we're going to have harder problems where you are going to have to set up those two equations. Let's take a look at another problem. Now this time, our example problem and our formula triangle are oriented just a little bit differently. So you have to really watch where your 30-degree angle is, where your 60-degree angle is, and where your 90-degree angle is. So I noticed right away that my longer leg is what's labeled with 10 centimeters. I know that that has to match up with x radical 3 on my formula triangle. So let's set it up. We have x radical 3 equals 10. Solve for x, I have to divide both sides by radical 3. And once again, I run into that problem where I have a radical in the denominator. So in order to get rid of the radical in the denominator, I need to multiply both numerator and denominator by radical 3. So clean it up. We have 10 radical 3 over 3. And this is an acceptable answer. Do not take 10 divided by 3 and get 3 1/3. Just leave your answer as is. So now I know, since we solved for x, remember x on our formula triangle is the short leg. So my short leg has to be 10 radical 3 over 3. Now on our formula triangle, we know that the hypotenuse here is twice the length of the shorter leg, which means I have to take my short leg and multiply it times 2. So I have 2 times 10 radical 3 over 3. So 2 times 10 gives me 20 radical 3 over 3. That is your answer. Again, I know it's not pretty, but that is the answer, and that is an exact answer. You do have homework tonight. Is the homework that is on your syllabus. It's on page 447, 477, 478, numbers 1 through This is sometimes a hard concept to grasp at first, but you do need to practice it. Help each other as much as you can. I will be back tomorrow and we can answer any other questions that you have and clear up any misconceptions.